My screen is visible, right?
Yes, it is visible.
Okay. And I'm audible clearly, right?
Yeah.
Okay. Good afternoon, everyone. How was the session yesterday, live session?
Yeah, it was good.
Okay. So this is another. So this is a live session for the second week, and in this week we'll be dealing with statistical test. Okay. In specific, the t-test, and again we will be learning about one tail, two tail, two sample, one sample t-test, and everything. Okay. So just to give a recap, this is a normal distribution, right? So can anyone remember what these two parameters are in the normal distribution? Like what is mu and what is sigma? Can anyone let me know?
Mu is the mean, and also sigma is the standard deviation.
Yeah. So one is mean, one is standard deviations, and accordingly, the curve, the probability distribution curve, also changes, right? And so the red one is the standard normal distribution, where the mean, the curve is centered around 0, and the standard deviation is 1. Okay. And it's is it a discrete or continuous probability distribution, and why is it so? Can anyone tell?
It's a continuous.
Why is it so?
The data
In which
points will be
aspect it
continuous.
is? Yes, the data points are continuous. That is the x variable, right? That is continuous. And moving on to the standard normal distribution case, this is how it's the probability density function, or PDF, looks like. Okay. And as you can see, around 68.2% lie of the values lie between -1 and 1. And almost 99.8% lies between -3 and +3. Okay. And again, as you can see, it's a bell-shaped curve, symmetric around mean, centered around 0. Okay. And if you substitute mu is equal to 0 and sigma as 1, you get this PDF. Okay. And this is the, so if you just substitute any x value, if I say x as 0, my value will be 1 by root 2 pi. That will be this value, almost this value. Okay. This is how you interpret the standard normal distribution curve. And you might have also gotten this decent idea about the standard normal distribution table, right? So anyone has any issues in reading this table? Okay, so I think everyone understood how this table works. Okay, just to give a brief introduction again, you have the standard normal distribution curve. It's centered around 0, and any value, let's say -3, if I take it here, this is minus infinity. Okay, this portion till -3, minus infinity to -3 is around 0.0013. That is what this table represents. Okay, and again, confidence intervals. As I told you in the last class, you can't take a sample of everyone in your school. Okay, you take multiple samples, like around 50 students each, come to a conclusion saying that the average height is around 170, but you might not be 100% sure of that. Okay, so this is where confidence interval comes in. You might be 95% sure that the average height of students lie in between this certain interval. That is your confidence interval. Okay. and this is a pictorial representation of it. So 95% confidence interval, that would be 2.90 to 5.62. And if you reduce your confidence, let's say 90%, the interval will become more shorter. Okay. And if you expand it, let's say 99%, the interval will be wider. That's the basic concept. Okay.
In that, why this
And
outliers?
can anyone let me know what does this Z transform do? Why do we need to do it? Anyone?
To get all data points in range.
All data points in?
Within that range, like for example, when the data points
Yeah.
are more.
Yeah. So again, you can't create a table for each and every mean and sigma, mu and sigma value, right? So you all convert it to the standard normal distribution form, and that was what. So the Z transform is quite popular to rescale features in your data set. Okay, to have mean 0 and standard deviation 1. Okay, and this is the formula that does it. Okay, for each data point, you subtract the mean so that the distribution gets centered around 0, and it's divided by standard deviation so that the final standard deviation for that specific data set be 1. Any doubts in this Z transform?
Yeah, can you go to the earlier side, the confidence interval? Why we have taken like outliers there, 2.5? Like that is because of the 99%. No. Or
Uh,
it is
I didn't get your question properly. Can you repeat it?
earlier slide confidence intervals. Can you explain it again?
Confidence intervals.
Earlier, before this.
This one.
Yes.
Okay.
Here,
So,
because the confidence interval, what we understood is from point to minus 2 to plus 2, it will be like 1.96. So the value we have to take, like, because both sides it will fall around 5%, it will come around half.
yeah.
So here,
So
the
since
yeah,
yeah, tell me.
here 2.5% what we have given, this is for the 95% confidence interval. You mean?
Yeah. So 95%, I can't be always 100% sure, right? If you're 95% confident means you have to ignore these 2.5% and the other 2.5%.
Here you have given two values just for comparison. Okay.
Yeah.
Yeah. Yeah.
So this is not a standard normal distribution. Okay. As you can see, the mean is 4.27. So these values, they don't mean anything. Just you have to ignore these 5% from either side.
Yeah. Okay. Fine.
Okay.
Okay.
Yeah. So this is the Z transform. Okay. You have the original value, you have the mean, and you have the standard deviation. And moving on to the T distribution, it is quite similar to the normal distribution. It's also continuous. And we use the T probability distribution only when the population variance is unknown. Okay. You also have a parameter called nu or called degrees of freedom or typically n. Okay. More if the more the degrees of freedom, you have a probability distribution that is more spread out. Okay. And can anyone let me know like what is the difference between population variance and sample variance? Like, can we always know the variance of the population? Can we know that? Do we know that beforehand?
So sample variance we can calculate, but based on that we can extrapolate it to population variance, whether it is matching.
Yeah, that is correct. We don't know population variance. We can't, there are around a billion people on Earth, so we won't know the population variance. So that is why we have to move on from the normal distribution to the T distribution because it might be more accurate to use the T distribution in this case than the normal distribution. Okay, and this is a visual representation of it. As you can see here, as the degrees of freedom keeps increasing, the distribution is becoming more and more spread out. Okay, and once it touches infinity, this black line here, what does it mean? Can anyone guess what does this distribution converge to when the degrees of freedom keeps increasing? You might have learned it in
I
the lecture, right? If it's more than 30 or something, we can use the normal distribution instead of the distribution itself. Okay. Was it there in the lecture? Okay. So the typical thing that you see here is if the degrees of freedom is greater than 30, this is like an arbitrarily chosen number. Okay. So as it becomes more and more, the t distribution actually approximates to a normal distribution. Okay. That's the basic difference between the t distribution and normal distribution. Okay. You have
can
another parameter called the degrees of freedom.
so based on degrees of freedom only, we can say whether it can be go for like t distribution or normal distribution, for example. Yeah.
So if your number of samples are actually greater than 30, it doesn't make a difference whether you use the normal distribution or the t distribution. If it's less than 30 and population variance is unknown, you have to go with the t distribution. Okay? You have to use the t distribution table instead of the normal distribution. Okay.
So at degrees of freedom greater than 30, both will be almost same. You are saying.
Yes. Both the normal distribution and t distribution will be almost same.
Okay.
Only when it reaches infinity, it will be exactly same.
Yeah. Because we from lecture we did not learn this. You are saying and we understood now.
Hmm?
In the lectures, this was not given, so we could not answer it.
Okay.
But the sample size, it was mentioned like it should be smaller. Like,
Yes.
yeah.
Okay. Mhm. Then again, properties of the t distribution. It is again symmetric around the mean. It's again bell shaped, and you have a parameter for mu. Okay, population mean, that is known. Okay, and standard deviation. As you can see, there is no sigma in this entire formula because we don't know the population variance. And once this tends to infinity, this will again gets converted to the normal distribution PDF. Okay. You don't need to worry about this formula, okay, since you already have the table with you. You don't need to worry about this. Okay, you don't need to remember this formula. This is just for your information. And applications for the t distribution as it goes, it is used for in cases when you have a very small sample size. That is what I told, right? Less than 30. And population variance is unknown or difficult to estimate. These are two specific cases where you have to use the t distribution. Other cases and financial markets, you can use it. And robust, it is a robust alternative since it's more closer to the, I would say, real world applications in case of small samples and population variance is unknown. Okay.
Can we say this way, like lesser the sample size, more the accurate t distribution will be?
Yes.
Okay.
This is another visual representation. As you can see, this is the t distribution when n is smaller than 30. Okay. And if it's very close to 30, you can see it almost approximates. It's not exactly the same. Okay. And as n keeps on increasing, the degrees of freedom keeps on increasing. This will, approximately be equal to the standard normal distribution. This is what the comparison is between these two. Okay. And moving on to statistical tests. Okay. Here we'll only be dealing with comparing means of two groups or a single group. This t-test is based on the t-distribution since we don't know population variance. And there are three main types. One is the one sample t-test, the second one is the two sample t-test, and the final one is the paired t-test. Can anyone explain what's the difference between these three? When do we use a one sample t-test? When do we use a two sample t-test? And when do we use a paired t-test? Based on these three types, again, your downstream analysis will differ. So,
One sample t-test is like studying only one set of sample and comparing it with a known value.
yes, that is correct.
And,
Yes.
and in two sample t-test, we'll be comparing two different groups, with, for example, drug studies and all. And
Yes.
in pair t-test, the sample will be same, the subjects will be same, and two different studies they will do, and they will compare both the values.
Yes, that is correct. Yeah. So, one sample t-test, you have a single group. Okay. And an example here would be taking the average exam score, and you have an expectation. Okay. The expectation will be your mu naught. And you frame a hypothesis. Okay. My null hypothesis will be my average exam score will be mu naught, that is in this case 80. And the alternate hypothesis, you can actually base it on whether it's one-tailed or two-tailed. Okay. And you calculate the t statistic from the table, from the data that is given to you, and compare it to the critical value from the table. If it's greater, okay, than the critical value, you reject the null hypothesis. Okay. I think there is a mistake in the slide. Can anyone say what the mistake is
So
here?
one tell you have written it as basically two tell. Mu is not equal to mu
Yes.
zero.
Yes. This is actually two tail, and this will be one tail. Okay. For the two sample t test, you have two different groups. One is A, one is B. My null hypothesis will be there is no difference between these two groups. Okay. And again, based on whether it's one tail or two tail, you can form the alternate hypothesis also, whether it's not equal to or whether it's greater than or less than. Okay. This is how you frame hypothesis in case of two sample t test. You have two different groups. Okay. Again, paired t test, you only have a single group. Okay. But then again, you compare the means before and after a specific drug is given to the patient or not. Okay. Another example given here is a newer study technique can improve test scores or not. So you recruit people from the same group, you ask them to study using their old technique, okay, calculate the average, that will be 75, and you introduce a newer study technique, and you have the hypothesis here saying that it will improve my test score. Okay. Again, based on how you frame these statistical tests, the calculation of the t statistic differs. Okay. So any research question that you encounter, you have to know whether it's a one sample t-test, a two sample t-test, or bad t-test. Okay? Because calculating this t-statistics differs from test to test. It's quite important and that you should remember. I'll do this is example calculation for the one sample t-test. Okay. I'm analyzing exam scores. My sample size, that is 30. Okay. My mean is 85. That is again x bar. And my standard deviation sigma is 5. My expected score, that is mu naught, should be 80. And I'm doing a one-tailed test. So what will be my alternate hypothesis? It's a one-tailed test.
Alternate hypothesis can be like observed mean is greater than the expected.
Okay, this is okay. And it's not observed mean, it's like the population mean. Okay.
Yeah.
This is your sample mean. 85 is your sample mean. Okay. And first you calculate the t statistic. Again, that is given by this formula. What is this s by root n mean or sigma by root n mean?
Standard error of the mean.
Yes, that is just an error. You calculate the t statistic. Okay. You find the critical value. My desired level of confidence is 95%. Okay. So again, my alpha will be 0.05. What are the degrees of freedom? How do you calculate it?
It's the n-1.
So that will be 29. Okay. Based on this, my critical value is around 1.699. Okay. And the calculated value is around 2.45. Okay. Can anyone use the, instead of taking the t distribution, can anyone let me know what's the value for 95% confidence interval for using the standard normal distribution? It's around 1.96, right? When you use 95% confidence, the z value, but it's still greater. So as I told you, when n is like close to 30 or greater than 30, you can actually use the normal distribution table also, standard normal. Okay. Since the compared calculated t statistic, since the calculated t statistic is greater than the critical value, we reject the null hypothesis. Okay. And we say that the mean is not. So rejecting the null hypothesis means it's not equal to 80. It will be greater than 80. This is my alternate hypothesis. Okay. Anyone got this? Should I repeat it again? Or again, as I told you before, null hypothesis is mu is equal to mu naught. I expected is 80. Alternate will be mu is greater than mu naught. Okay. Since the t statistic is greater than the critical value, I am rejecting the null hypothesis and saying that my population will actually be greater than 80. Okay. Any questions?
under what conditions this same pattern will become like, for example, two sample t-test? For example, if you change something here, then
Huh?
and what under what conditions this one sample t-test can become two sample? For example, based on this
Okay,
question.
okay, okay. In that case, what will happen is in the two sample t test, when you get the critical value, okay, what will happen there is the critical value will change. Okay,
Okay.
you have to actually take it for 0.025 alpha. Okay, that is
Hmm.
one thing. And the calculated t statistic should be greater than the critical value.
Okay.
That is one thing, or less than minus critical value. Can be both ways.
Hmm.
So it can be at the either end of the tail. Okay,
Okay.
so that is how you convert it over to a tail test. Two tail test.
Yeah, yeah.
Okay, any more doubts? Okay, moving on. Hypothesis testing and the types of errors. Okay, hypothesis testing, you have certain claims, okay, about populations that you want to verify using different samples. That is what the hypothesis testing framework is designed for. The null hypothesis, as you have all seen till now, is a statement about the population that you always assume it to be true until proven otherwise using all these statistical tests. Okay? You always frame the null hypothesis in such a way that you assume it to be true. Then the alternate hypothesis will be opposite of your null hypothesis. Can be greater than, can be less than, or just not equal to. Okay? And two types of errors can occur. One is the type 1 error, one is the type 2 error. What's the difference between these two? What is a false positive and what's a false negative?
In type 1 error, we uh, reject a true null hypothesis. In type 2, the opposite, like failing to reject null hypothesis there, even though it is true.
Yeah, that's correct. So first one is the type 1 error. Type 1 error, you reject the null hypothesis when it is actually true. Okay. And what does this mean downstream? Okay. You are rejecting the null hypothesis when it is actually true. So you are coming to an incorrect conclusion, saying that the new treatment or newer drug has a significant effect, but in actual reality, it does not have any effect. Yeah, according to the null hypothesis. And the consequences for this can be, wasted resources, misleading conclusions. And let's say when this type 1 error is actually high, you introduce this newer drug into the market, okay, and people still don't see any effect. Okay, so you want to avoid this as much as possible, and you can actually control this type 1 error, okay, by setting the significance level, that is alpha. And when you that is why people always take around 95%. Okay, when you control, we can actually control this type 1 error by setting it to be 0.05. It's quite a good trade-off between controlling type 1 error and type 2 error. Okay, an example would be you claim a new drug improves health. Okay, You come to a false conclusion, you put it in the market, but the effect is actually too absent. Can anyone tell me, like, how do we reduce type 1 error?
By decreasing
Should
p-value.
we increase alpha or decrease alpha?
Decrease.
Actually, increase alpha.
Uh,
Okay.
so it will be, if to increase the error, it will be the opposite.
Mhm. So again, type 2 error, it is failing to reject the null hypothesis, okay, when it is actually false. You're actually missing the effect that the new drug actually has. And again, this can lead to various consequences. You actually have the effect and you won't be putting it in the market. Okay, missed opportunities, missed profits. And type 2 error, you actually control it by setting something called the power level. Okay, that is 1 minus beta. Beta is also called statistical power. Okay, statistical power. So, was this taught in the lecture about beta, statistical power, and so on?
It was said like power of test for the distribution. Beta error means p x epsilon r.
Can you repeat it? I didn't hear it properly.
It was said like power of test for the distribution, the beta error. And, it is p x epsilon r.
Okay. Like, what does statistical power mean? Like, anything was taught in the lecture, or?
No. Just a definition was given.
Okay. And actually, so I think I made a mistake here. It's actually you should decrease alpha for reducing type 1 error. It's actually not increasing it. Okay.
Yeah. Okay.
Yeah. Mm, yeah. Again, an example here would be, so air pollution and lung cancer actually has an effect, but incorrect statistical analysis led to say that the link does not exist between air pollution and lung cancer. Can be, this is quite an important finding that is overlooked. Okay. Okay, and this is the trade-off. Okay, reducing alpha decreases type 1 error, but increases type 2 error. Okay, and what can we do to reduce both simultaneously is the only way of doing it is increasing sample size. But again, increasing sample size, what are the disadvantages associated with getting increased sample size? Anyone?
So it will go towards the normal distribution again.
No, that is fine. What are increasing sample size? What are the disadvantages, or why can't we do it?
Data analysis will take more, consume more
Oh no,
resources.
data analysis. We have faster computers right now. That won't be an issue.
Okay.
But actually, recruiting people for the study, the cost will actually increase, right? When you test more and more individuals, so that is
Resources.
prohibitive. So these are the practical limitations, and so we have to frame the research question properly, analyze the trade-off between type 1 error and type 2 error. You have to decide whether you want you are okay with false positives or you're okay with false negatives. You have to decide that trade-off, and Okay.
And in order to keep this both errors within the lesser side, in order to keep the in order to maintain the to keep the study error free. So what will be the sample size required? Is there any threshold? This much only sample you have to go with that,
So,
so that no error will be there.
I mean, we can't always achieve a zero error because only zero error can be achieved when you sample everyone on Earth. That is practically impossible.
Yes, yes.
So again, you again have this confidence levels, right?
Yeah.
So there you can actually calculate the minimum sample size as given in your first week assignment.
Yes, yes.
So again, if you want 99% confidence level, accordingly you can take that specific sample size. So that
Yeah.
depends. Okay.
There we are sure that the errors will be minimum, like not more.
Yes. Yes. Yes.
Okay.
This slide actually, combines what I've been talking about in the previous few slides. I'm testing a new drug for reducing blood pressure. What is the type of error is? Claiming the drug is effective and it actually isn't. And doctors are prescribing it to the masses and everyone is getting side effects. In the type 2 error case, actually it can treat blood pressure, but based on my statistical analysis, the and based on this type 2 error, I'm not introducing it to the market, and we can't treat blood pressure more effectively because we missed a truly effective drug. Okay? And again, balancing these errors, you have to take care of it. Okay? This is a question on using Z transform. Can anyone work this out and let me know what the answer is? Okay, I'll give you all 10 minutes. Work this out, and I'll also be solving it once you're all done. Okay? It's based on the Z transform. The formula is x minus mu by sigma. So this is the Z transform. Okay, and you're assuming a normal distribution. Keep this also in mind. Anyone got any idea how to solve it?
The answer is 0.7057.
Can you explain me how did you arrive at that answer?
Sir, the question was asking average is 2.5 centimeter and
So what
SB
is
is 0.3 centimeter. So
so mu is 2.5,
mu is 2.5. According to
sigma.
Z, sigma is 0.3.
Yeah, okay.
So now the question asks of what percentage of sunflower stalks will have diameters between 2.2 and 2.8. So first
Yes.
we'll find Z for 2.2 centimeter. So that will
Hmm.
be 2.2 minus 2.5 upon zero point 0.3. That will lead to minus 1. So the Z score will be 0.1356
Hmm.
for
No,
2.2.
no, no, no.
And
So actually, z will be minus 1
hmm,
to plus 1, right? So it will be minus 1 in the case of 2.2 centimeter. In the
2.2
case of 2.8, it will be plus 1.
plus 1. Yes, sir.
And from the table, how many percentage of values lie between minus 1 and 1?
So
It will be
I
68%.
Yeah, it will be around
okay,
68%.
okay,
You have to do the subtraction properly.
okay, sir.
Okay. Anyone has any other doubts in this question? So basically, what we did here is my initial x1 is 2.2, so it will be 2.2 minus 2.5 divided by 0.3. That will be minus 1. That will be my first z value. My second z value will be 2.8 minus 2.5 by 0.3. That will be plus 1. Okay. So my z is minus 1 and 1. Okay. It will be in this range. And if you go to the standard normal distribution table, you can calculate values for minus infinity and minus 1, minus infinity and plus 1. You subtract these two, it will come around, I think, 68.57%. Okay. And moving on to the next question. Calculating standard error. Can anyone tell me what will be the formula for standard error?
It's a S
What's the
by root
formula?
square root n. Standard deviation by square root n.
So, yes. And what is standard deviation?
Sum of squares by n minus 1.
So it will be around square root of 1 by n, summation I equal to 1 to n xi minus mu square. Okay. So these are the two formulas you have to use. And so first thing, can anyone calculate the mean and tell me what it is?
Mean is 13.6.
Okay. Then what is sigma?
Sigma is 5.33.
5.33.
33.
Okay. Is everyone else getting the same answer? So I have not calculated these values. So can anyone else also verify if this is correct? It will be good.
Standard error coming around 1.68. Let me confirm it
Okay.
also.
Is anyone else getting the same answer? Or anyone else is getting it something different? So is 1.68 correct? Anyone?
Yes, the sigma is 5.33 and standard error is 1.68. Correct.
Okay. Good. The next question. This deals with the coefficient of variation. There are two groups of genetically distinct plants taken from two different populations. They are grown under identical conditions, there's no difference, and the coefficient of variation per the length of the leaf is found to be same. Okay. The average leaf length in population 1 is 1/3 of the of that of population 2. If the average is like this, what will be the ratio of standard deviation in population 1 to that of population 2? So what is the formula for coefficient of variation?
Sigma by mu into 100.
It's sigma by mu. So if mu1 by mu2 is 1/3. My question is, what will be sigma 1 by sigma 2? What will be this ratio?
1/3.
Yeah, since CV1 equal to CV2, the ratios is also the same. Okay.
Yes, sir.
Any doubts in this? The next question. This is about confidence intervals. Okay. So, your company manufactures artificial tendons with an average tensile strength of 10 meter newtons per meter square, and a sample of 10 tendons is measured, and the mean tensile strength is around 8. Okay. What is the minimum standard deviation for this sample set to conclude with 95% confidence that it comes from the same population as the manufacturing process. So what is the research question here? Or what type of test that we should use?
One sample t test.
Yes. And what's the formula?
T is equal to x minus mu 0 upon standard deviation square root n.
So it's given 95% confidence. Okay. You have the sample mean, right? This is there. Mu naught, that is given. N is given. T you can calculate it from the table. You need to calculate sigma. Okay. So again, first thing that you should do is what should be the T value for 95% confidence. Can anyone? So okay. One more thing. First thing, degrees of freedom.
Yeah, we should know this. Then only we can the value.
So what is the degrees of freedom? What is the degrees of freedom here?
It is a 9, I think.
Yeah, it should be 10. N minus 1. That is 10 minus 1. That is 9. Alpha is 0.05 cents. It's 95% confidence. So these two are given. What will be my T value?
It's I think 2.262.
It's around 2.462.
262, I think. 2.262. 2.262. 2.262.
Okay. Yes. So everything is given. Rearrange the formula. And can anyone let me know what's the final answer for sigma is?
$2.793.
Okay. Anyone else is getting the same answer? Anyone else? Same answer?
Yeah, 2.79.
Huh?
2.79. Yeah, I think
Oh.
it's correct. Yeah.
Okay, it's the same.
Yes.
Okay. Yeah, good. And then Moving on to the final question. Okay. We have researchers investigating the effectiveness of two different fertilizers A and B for a certain plant growth. They grow 15 plants under each fertilizer treatment and measure their final heights. And the research question they have here is there any significant difference in average height when using fertilizer A and fertilizer B? And this is the data that we have. Using fertilizer A, my mean height is 25 centimeter, standard deviation is 3 centimeters, and sample size is 15. And when using fertilizer B, my mean height is 28 centimeters, standard deviation is 4 centimeter, sample size is 15. So this is two sample t test. Okay. Game. I'll give you all around 10 minutes. Try to solve this question. Try to gather all the formulas that you have learned for the two sample t test. And then once you are able to solve it, I'll be solving it again. Okay. You have data. You have x bar 1, x bar 2. You have sigma 1, you have sigma 2, you have n1, n2. Okay. We can take alpha 0.05 and if it's okay. You have to combine both. Okay. Both the standard deviation, both the sample means. Calculate single t-test statistic. And one more thing. First thing, what's the degrees of freedom here in this case? Degrees of freedom.
I think it is 28.
Yes, it will be n1 minus 1 plus n2 minus 1. That will be 30 minus 2, 28. Okay, 28 is correct. Should this be a two-tailed t-test or one-tailed t-test?
Two tail.
Yes, two-tailed. We don't know for sure whether there is an increase or decrease. So what's the formula for the T statistic? For the two sample T test, anyone?
X bar high minus X bar L divided
Can you
by
repeat it?
X bar high minus X bar L divided by
Minus X bar
2 divided by
divided by,
SP, that is standard error,
yeah,
square root 1 by
1
n
by
1 plus
n
1 by
n2. Is this correct?
oh, that is standard error into square root.
Huh?
Standard error into square root of 1 by n1 plus 1 by n2.
I didn't get you.
The denominator should be standard error into square root of 1 by n1 plus 1 by n2.
Yes, standard error times 1 by root of 1 by n1 plus 1 by n2, right?
No, I think not divided by, it is
Yeah, it
standard
should
error.
be multiplied. Yes, yes, yes. And how do you calculate the standard error in this case?
That will be square root of n1 minus 1
Yeah,
s1
that will be
square
n1 minus 1 sigma
s1
1
square
square
plus
plus
n2 minus
n2
1
minus 1,
sigma 2 square
yes, divided by
divided by n1 minus 1 n2 plus n2 minus 1
n1 minus 1,
plus n2 minus 1.
yes. Okay, it's the formula. First, try to calculate standard error and give me the answer.
The calculated t-value is 2.325.
Huh?
Calculated t-value is 2.325.
Okay. T value, one answer is 2.325.
And
What's the
table
critical value?
critical value is at degree of freedom 28 alpha 0.05 is 2.048.
0.048. What's it for alpha by 2?
I've not checked it. Just a minute. One 1.701.
Okay. So since this is a two tail, you should always calculate it for alpha by 2. Okay. 1 point.
Okay, sir.
1.701.
1.701.
Okay. Should we reject the null hypothesis?
Yes, sir. We should reject the null hypothesis because calculated t-value is more.
Yes. Is anyone else coming to the same conclusion?
Yeah.
Okay. So, you all have any other doubts in the assignments?
Sir,
But
I
if you
have
have,
doubt.
yeah, tell
In
me.
the week 2 assignment last question, it is the same question, just like this. Two sample t test. We have
Yeah.
calculated all the thing. The t calculated is more than table t, but I
Okay.
cannot get it from the question that whether it is one tail or two tail because the options were given like a drug A is better than drug B or drug A is worse than drug B. But I cannot get the exact answer because of this reason, because it is whether it is two tail or one tail, the question is not uh, easily understandable.
Okay. What are the options given?
Just a minute, I'm opening it.
Yeah, sure.
So options were like this: can drug A is better than drug B, drug A is worse than drug B.
Okay.
And another options, I cannot open it somehow, I don't know, but I cannot get the proper answer for this.
Why you're not able, since it's greater than or less than is given, right? So you
Yes,
should
yes.
obviously be a one tail test.
Okay.
Yeah. And you are comparing between two samples. Same, similar to this. The greater than or less than part, that will come when the t statistic is like positive or negative in that case. So
Another two options are drug A is as good as drug B, so it's not possible, and drug A and drug B are not good.
drug
And the
A and
question
drug B are not
B
good.
are not good. And the question was just simple. The two drugs A and B were tested on 10 and 12 subjects respectively for lowering blood urea, and the
Okay.
data, that is urea amount, are given below. At 95% confidence level, average urea for drug A and drug B are given and standard deviation is given. So they have not
Okay.
mentioned the whether the tail is whether they want to check the one tail or two tail test. That's what I cannot get from it. So that is one
Yeah.
tail test when it is not been given. Sorry, two tail
Yes.
test when it is not been given, right, sir? So why they are mentioning these two options then? They are mentioning
So
four
the third
options.
option is drug A is not as good as drug B.
No. First is drug A is as good as drug B. That means it is null hypothesis. That is not possible.
Yeah. That is
Then
there.
second
Yeah.
option is drug A is better than drug B. That is
Okay.
not been
That will
given.
be
This one till is not been given in the question anywhere.
okay. Yeah. So you can frame that as the alternate hypothesis and then do the test,
Okay.
right?
Okay.
Yeah.
Okay.
So yeah, according to the options, you can also frame your hypothesis.
Okay. And then we can check it. Okay, sir.
Yes.
Okay. Now I got it.
Um, anyone else has any other questions?
I think second question also.
Which is, can you repeat the question?
With respect to the Q1, if the probability of occurrence of a bolt of certain diameter is 0.1469, what is the diameter of that bolt? This is quartile, I think, quartile 1.
No. So I mean that is based on the previous question one. It's not
The-
Q and Q that quartile. It's like based on question 1.
Okay.
Again, if the probability value is like 0 point something or something that's given.
And in the first question, we have to calculate the z value, right?
Yes.
No, z will be
Yes.
-2 plus 2. So based
Mhm.
on that, it is coming 10 and 14, but options I have not seen here. Those, can you
Yes, sir.
share?
Same question. The
10 and
options.
14?
It's a numeric question, right? That you have to type in the answer, right? It's not like that, or
No, sir.
Here,
Options are given.
okay. What are
We
the
have to
options
choose
given?
one.
so what we are getting is, I think 10 and 14, but
Yes,
here I
sir.
have
10
Okay.
and 14 is the answer. Options are first is 8.5 and 9.5. Second is 12 and 13. Third is
Okay.
9 and 11. And fourth is 13 and 15.
Okay.
But yes, the answer which is spoke was right, 10 and 14.
Okay. So can someone put this question in the discussion forum actually? Maybe we can try to check the question again and let you know what the actual answer is. When is the assignment deadline?
7th February.
Okay. We have time. Okay. Can someone post this question in the discussion forum?
Okay, sir.
Yeah. And then the second question, that will be like you have the p value. Okay. P value is what does it correspond to in the PDF? So that will be your area under the curve or something, right? So from this p value, you get your z value. Based on this z value, you can actually get your x. That is how you solve the second question. Again, same z transform.
okay.
Any other questions? I think most of the
These
yeah,
questions,
tell me.
first one and last one, only we had some problem. Other questions are fine.
Other questions are fine. Okay. Yeah, just post these in the discussion forum.
And also, I
And
wanted
also,
to ask you, you have created this YouTube link for the first week session, and also for this one. Can you share us? We also will go through again so that we will be more clear before going for the other assignments.
okay. Are the yesterday's one that is posted or not there?
Yesterday's one is not posted, but before that he has posted. Yesterday's one also he may post in the group or something.
Okay. Because last time when I recorded, the recording actually crashed in between, so I couldn't do it. So day before yesterday only, I re-recorded it and uploaded it. Put the link. So I think it will be updated in a few days.
Where it will be? It will be in the same NPTEL only, or you will give us.
Yes. Same.
Okay. He has given us the
Where did
link,
you get the previous link? Do they have a forum for that or?
and also can you share this also so that we can spend some more time on this?
Yes. So I have shared both the slides and the recording. But here the slides, do you want with the annotation or without the annotations?
With the annotation is helpful.
Okay. Then I'll do that. Okay.
Okay, fine. Thanks. And can we contact sometime, like when we get some more doubts, like if you are not clear with the things? So can we contact you?
Yeah. So you can write an email to this address or also post it in the discussion forum. I'll be answering the questions there.
Sure.
And so you have all started reading any reference books or?
Yeah, we are spending some time on books also. It is required, I think, because understanding question is a bit tough for new people like me. We are reading like NCERT books also somewhat helpful, and also
Okay.
some more books are suggested by the uh, professor coordinator also. So we are trying to go through.
Okay. So We still have time left, so if you ask any questions or doubts about the course or any concept that does need explanation, I can answer. Or if you don't have anything, we can close the session.
So during the exam, whether we have to calculate by, like manually or because system support will be there anyway, can we also go for a graph pad calcs, quick calcs also? Can we use it or we have to go only
I
for
think
the
only a
manual?
calculator would be provided.
Uh-huh. Okay.
And maybe if they ask for any confidence interval, they won't ask for like 99 or 90%. 95% would be the standard one, so that you can actually memorize. So since 95% confidence interval, if it's standard normal, you must know the value would be around 1.96. So,
Uh,
or else if they don't provide you with the values, they'll also provide you with the table, I guess.
okay.
But some of the common values you should remember. T distribution you can't because there are different degrees of freedom, but at least for the standard normal distribution case, you can remember some values.
Yeah, yeah. And one more thing is which test we have to choose also from the question we have to understand clearly. Then only we can.
Yes, yes,
That is very critical sometimes.
yes, that is. So once you frame the question, I mean, automatically you will get what type of test to choose, what statistical test to choose, and what conclusions we should arrive at.
Okay. And one more thing, the assignments what we have submitted, assignment one, how we can come to know the score and all? Will you share us in the same site or?
Score, I think it will be automatically graded, right?
Because we want to know whether we have done the correct answers or not. So what is the score and all?
Okay, okay, okay. I'll check with the coordinator here and let you know.
Okay.
I think solutions also will be released before your exam, but let me check with them.
And in the final exam, the score required will be like the in order to get pass kind of thing. It is like grading from the assignment also will be counted, right? 30 to
Yes,
70
yes, yes, yes. Assignment also will be counted.
Assignment will be 30% score.
Yes. Mm-hmm.
And the 70 from the main exam.
Yes.
Would it be possible to share the videos before 7 the deadline of the first assignment 2 also, so that we can be more
Okay, okay, okay. I mean, I can't put it. I'll just put it in my sheet. Like only people from NPTEL can upload it.
Okay,
But
okay.
yeah,
Because
I
big
think.
three.
But if you search for my channel in YouTube, you can actually get it. I guess it is. I think Roshan MSP. I think week one should have already been uploaded there.
Okay, tell me the name.
Roshan space M space
N.
S space B. Roshan MSP as written here.
Okay.
Are you able to get the channel?
Yeah, week one is uploaded. I can see
Okay,
that.
okay. I'll upload week two shortly.
Yeah, sure.
Okay. Okay, if we don't have any other questions, we can end the session.
Yeah, okay, fine, no problem. Thank you.
Yeah.
Thank you so much.
Thank you. Thank you for attending this session.
Okay, bye.
Yeah, thank you.
Thank you so
Thank you,
much.
sir. Thank you so much, sir.
Huh? Okay.